So you are welcome to another edition of Verse, which is the most important aspect of essential keyword in statistics. So far, so good. We've talked about data collection, data organization, and here we want to talk about data analysis. And of course, for you to analyze your data, the first thing is to set your objective, the reason why you want to analyze, why you are conducting your study. And the next one is collect the data. After collecting the data, so you perform you organize it, then you begin your analysis. Although sometimes you can say that even data science is part of data analysis. So I will just say subset. So, so, so data analysis is just analyzing the data you might have collected to get trend or pattern hidden in the data. So here you determine the statistical test or model to use when analyzing your data. And this test, you don't just choose any test. It depends on the data type or the type of variable or the phenomenon under which you are trying to investigate. So data analysis is very, very important in any research, or if you are a data professional and you don't know anything about data analysis, then you shouldn't be called a professional in the first place. Because you show your professionalism is the aspect of what data analysis. So what method do you use to analyze data? So that can be categorized into two, which is descriptive statistics and inferential statistics. So when you say descriptive statistics, it's just to describe information about data. When you say descriptive statistics, it describe or explore information about data. So when you now say inferential statistics, it make make information about a population based on trend or based on the pattern observed from what sample. In our first class, we talked about sample and population, but I can see I mention that again. Just the population is just the whole entity that you are trying to study. A wide sample is the subset or fractional part of the population. For instance, now, population of Nigeria, we have about 2 million in population of Nigeria. So if you want to understand the political apathy among Nigerian population, so it's not possible for you to investigate each person that we have in Nigeria. You just have to sample, maybe in each state, to sample a particular number of respondents. So now what? You investigate them, whatever you response you got from them. So when you sample them, whatever you get is a sample. So the response you now get from the sample, you can use it to make inference, to generalize about the word political apathy of the whole population in Nigeria. So when you're talking about data analysis, there are two methods, which is statistics and inferential statistics. So we'll be talking about this one by one. So when you say descriptive statistics, it's just a branch of statistics that involves summarizing variable or variables for a sample of data. For a sample of data. That is just it. It just involves summarizing or describing a variable or some variable for a sample of data. So it might be one variable, right? Maybe you want to summarize just a single variable. In that sense, we call that univariate analysis. Maybe you want to describe relationship between two variables. In that sense, we call that bivariate analysis. Bi from the word two, then variate analysis from the word variable. Or maybe you want to even explore the association among three or more variables. When you have three or more variables, so we call that multivariate analysis. Call that multivariate.
Sit down. Sit down. It's Abu
Please,
Sufyan.
Mrs. Salaudin, can you please mute yourself? Please. Thank you. So, for multivariate analysis is when we have 3 or more variables. So we are not going to cover this in this lecture. We talk about one variable analysis and two variable analysis and what kind of descriptive statistics method you can use for those. So here, if you have just one variable, the one variable that you have, is it a categorical variable? For instance, marital status. If that is the case, then you can use frequency table or bar or pie chart to describe or to summarize that information. And thank God we've talked about frequency tables and bar chart, pie chart under data organization. So if you haven't watched that, please, you can try to watch the previous video to know marital status is categorical and that is qualitative, like married, single, divorce, widow, and so on and so forth. So if you want to summarize variable under this marital status and you want to summarize the information that marital status, okay, you can say that okay, maybe 73% of the respondents are married or 20% are single based on the information you have gotten from your frequency table or batch chart or pie chart. We did this in the next class, in the last class. So, so let's not assume the variable you want to summarize is continuous variable. In this case, which is quantitative continuous variable. This might be discrete, this might be any other one, but continuous variable in this case. So example is temperature, pH, height, weight, concentration, dose, and so on and so forth. So for you to summarize this or to describe this, you can use histogram or box plot. You could remember that. Then you can use mean, median, or mode, or even standard deviation. Mean is just the average value of the variable you are trying to summarize. So the median is the mid value, the mode is the most occurrence value. The mode is the what is the occurrence value, most occurrence value. So the standard deviation is just the the dispersion, the dispersion of the variable you are trying to what, summarize. So this standard deviation, it is called risk when you are analyzing stock in financial stock analysis. So the images of this standard deviation are made the images of them very well. So the continuous variable here can be summarized using mean, median, mode, also known as measure of central tendency or standard deviation range. There are more than this, but this one is also known as the measure of what dispersion. So let's now assume that you are trying to summarize two variables. Are the two variables categorical? In this sense, gender and race. The gender is categorical, race is also categorical. So let's assume you want to summarize them at the same time. So in that sense, cross-validation. In this sense, gender will be on the column and race will be on the row, vice versa. Or you can even use the four-star star of column chart. So we talked about this last class, although we didn't mention it. We talked about it last class. So if the two variables you are trying to summarize are continuous versus continuous, like age versus weight, BMI versus height, and so on and so forth. In this sense now you can use what? Scatter plot. Scatter plot. So you just explore the relation between the two variables. And don't forget, what descriptive statistics did was to describe or explore or summarize the information of what gotten from a particular variable or two or more variables. So which method we now use, it depends on whether the variable is categorical or continuous. In another way, maybe whether the variable is quantitative or qualitative. So that's about descriptive statistics. So next now is to move to the inferential statistics. So before I move on, so I would like to ask if you understand what I've been talking about so far and maybe you have any question you want to ask me. If there's no question, you can please quickly say something so we can move on to the next class. Any question? I'm still waiting.
We are good, sir. Please continue.
So, descriptive statistics is summarizing data or variables. But if you want to use the summary of that variable to now make inference to a larger population, then we have what? Inferential statistics, which involves drawing conclusions about population based on information obtained from sample, which is the fractional part of the population. And that sample must be from which the population was done. This one is often involved too, which is estimation and hypothesis testing. Yeah, there are lots of things. When you say estimation and hypothesis testing, so there are lots of things embedded in it, but I won't have to depth more since most of us there are non-major statistics. So practitioner here will know what I mean by something. So when you say estimation, maybe you want to estimate sample mean to generalize information about population from which the sample was drawn. So let's assume uh, you want to study a population of of a market a market woman. Maybe you want to know what they earn, and this market their population have a lot. Let's say we have 500 samples. Since asking them one by one about what they earn in the market will take a lot of time. Why don't you select small part of the population, maybe 50? Ask them about what they earn in the marketplace, take the mean, and use that mean. I mean, when I say mean, average, and use that average to generalize information about population from which the sample was done. And the population from which the sample was done here is what is the market woman. What did you estimate? You estimate what? The mean of what? Of their average wages in marketplace before you now generalize it. So another one is that it might even involve hypothesis testing. This happens a lot in statistics or in research. So it's just about formulating a statement about population based on information observed from the what? From the sample. Formulating a statement about population based on information observed from the sample. When I say statement, hypothetical statement. So let's just leave it here. So because there are a lot of things embedded in it and we have to talk about it at 2, 3, 4 classes. We have not finished it. So this is just know that inferential statistics is what? Making inference to a larger population from what? The sample. From the what? From the sample. So that is inferential statistics. And I told you the other time it's called hypothesis testing. And what kind of test? How do you know which kind of test to use when involved in inferential statistics? The first thing is that do you want to do comparison test or associational test? I mean, comparison test, maybe you want to compare between groups of qualitative variables. So that's what I mean by comparison test. If you want to talk about comparison test, then you can talk about either t-test or ANOVA. That's what is used to compare t-test, ANOVA. If it's t-test, when do you use t-test? You use t-test when you have categorical variable versus continuous variable. And mind you, that categorical variable is just have only two levels. For instance, sex, male and female, it has only two levels. Yes or no, variable with yes or no response is just two levels. That is very, very important. If there are more than two levels, you cannot use t-test. So if they have two levels, then that is part of a continuous variable. Then you use t-test for that. Example here is sex, which is male and female versus BMI. That is, you want to know maybe there is difference in the body mass index of male and female of a particular population. Body mass index is continuous variable. Male and female, sex is what? Is a categorical variable with just two levels, which is male and female. In that sense, we use what? T-test. Hello? Can you hear me? Hello?
Now, I
Okay.
can hear you, sir.
So my connection just lost my phone. That was why I asked if you can hear me. So let's continue. So yeah, that's that about that. Now, for the ANOVA, it's also comparison test. That is when we also have categorical variables. But this one has three or more levels versus a continuous variable. E.g., level of education. When you say level of education, you have primary, secondary, tertiary, MSc, PhD, and so on and so forth. They have three or more levels. If you want to compare them with job satisfaction, maybe in a particular organization, you want to compare the employee job satisfaction based on their level of education. You want to check maybe they have the same rate of job satisfaction or their job satisfaction is different. So since we are comparing with level of education in this sense, we are going to use ANOVA. And before I move on, this tip test is just tip test, but there's something we call paired tip test and independent sample test. In fact, there's also one we call one sample tip test, but that's not what we are going to discuss in class. So this class is just to know which kind of test, which kind of analysis to use based on what? Your data and based on your research questions or based on your hypothesis or objective, the reason why you are carrying out what? Your analysis. So if it is associational test, you use regression or Pearson correlation or chi-square. When do you use regression? That is when you have continuous variable versus continuous variable. That is, you have two continuous variables. You can use regression here or correlation. That is BMI versus diabetes. You wanted to check the difference between BMI, the relationship between BMI and what? Diabetes. You want to tell maybe if BMI of the particular respondent is high, diabetes is high, and so on and so forth. But when do you use chi-square? You use chi-square when you want to find the relationship between two categorical variables, that is two qualitative variables. That is when you use chi-square. Example here is just race versus religion practice, maybe in Nigeria. So in Nigeria, we have Hausa, Igbo, and Yoruba. We have that's categorical. Then religious practice, we have Islam, we have Christian, maybe any other one. That is another category. So you want to check the relationship between the two. You want to check the relationship between the two. So in this sense, now you use chi-square. The t-test, the ANOVA, the regression or Pearson correlation or chi-square, they are the five most commonly statistical tests used what to analyze our data, and that's why I briefly made mention of them here. Because here we are talking about applied statistics, not advanced statistics. So we want to talk about advanced statistical tests. We have a lot of them. Um, you can reach out to experts based on your own study. So, but if you are just a data analyst, you are not into a lot of research, this is enough for you. If you are just a data analyst, this is enough for you. This is enough. So that's that about inferential statistics and descriptive statistics. So before we move on to the summary, so type of data analyst. All these persons here we have here, they are data analysts that we have. Quantitative analyst, market research analyst, business intelligence, IT system, operation research analyst, medical and healthcare analyst, intelligence analyst, and so on and so forth. All of them, if they have no knowledge of statistics, you don't need to call them analysts. All of them, what I discussed in the previous slide is what they use mostly in their work, in their analysis, in their analysis. You know, this quantitative analysis, so we're talking about advanced research. Here we are talking of medical research or research in agriculture or in education and so on and so forth. So these are the type of data analysis that we have. And there can even be more than this. So if you have someone and say, okay, I'm a data analyst. So what kind of data analyst are you? Who? Are you a quantitative data analyst or market research analyst or even powerful business intelligence analyst or medical and health analyst and so on and so forth. So on and so forth. So if I'm a data analyst, it means that I'm all this. So any work that comes from this aspect, I can handle them. That's what it means. But without the knowledge of, so these are the text and skills that it require. SQL for database, Excel, Hadoop, Oracle, Tableau, Python, R, SAS, eView, Tata, JMP, Jamovi, JASP, and so on and so forth. So I can use Hadoop. Personally, I can use Hadoop, I can use Oracle, and I can use SAS. So you can't use it. It's not necessary that you be able to use everything. So it's not possible. But the one method that you know or the one skills that you have as a data analyst, you make use of them very well. So all these tools, all these skills, they are not necessary. They are not even useful without the knowledge of statistics. So there's something you want to use Tableau for. You don't know how to analyze your data, either Python, R, or SQL, Excel. If you don't know what you want to do with your data or the tools you are going to use, the statistical method you are going to use, all these things, they are irrelevant. They are irrelevant. So that's why I was talking about them before I brought this here. So look at this funny picture. Data analyst experience. Analyst experience, I can use Excel, I can use Python, I can use Power BI, SQL, a lot of package. But without knowledge of statistics, you are inside water. You don't know anything. So if you want to be a data analyst or research analyst, so you have to know a lot about statistics. So just the basic one that I just mentioned, but if you want to go higher into research, then you have more work to do. So look at them. Look at them. They got their work. They are struggling work in the knowledge of that. So let's take that very important. So in summary, which statistical test will you use? And although I've talked about this before, but there's a reason why I brought this here as summary. So if you want to check the source, this link is available here, or I can post it in the group so you can check it online. So which statistical test to use? So tomorrow, tomorrow there will be another class, and that class will be more practical. I will come with some practical questions, a lot of them. So we did it to be interactive. You now tell me, okay, based on information from this question, from this, what I will be posting. So this are the kind of test to use, this kind of test to use. But before that, you have to read this slide again, or you can just click this link. I'll post it in you and I read a lot about it, or I post the video on the group so you can watch it before tomorrow. So let's just create that. We talk about data analysis, data statistics, and data statistics. So if you want to know the kind of test, are you talking about are you talking about continuous data or you are talking about what? Discrete data. If it is discrete, that is categorical chi-square test. So you about that. If it is continuous, is it relationship which is based on association? Is it differences which is based on comparison? If it is relationship, you have regression analysis or correlation analysis. Two independent variables, don't worry about that. Just regression analysis and what correlation analysis. Also, don't worry about whether it is parametric or non-parametric. Leave that to statistician and leave that up for those that want to go depth in what in research. Just know that regression analysis, correlation analysis, and if it is differences, equal variances, if it means two groups, then you can talk about two groups, you can talk about student PSC test or PSC test. If it is more than two groups, you can talk about what? ANOVA, ANOVA, so and so on and so forth. So when you talk about parametric assumption, leave that. Invariant sample, data normally distributed and homogeneity of variances, that is not above this class. That is above this class radar. So here is just to talk about the kind of test that you are going to use in your analysis. So I'm sorry I'm too fast because we are running out of time. We have less than 8 minutes to ask any question, or if there is anything that is not clear to you, you can just make mention of that so I can talk about it. So the floor is open.
Well done, sir. Please, the first question I would like to ask is, please, what's the full meaning of BMI?
BMI is body mass index. It's just a variable in that is very common in research in medical line. It's body mass index. Body mass index. How do you measure body mass index? Just your weight divided by your height raised to power 2. So that's it. Body mass index. So for more, just go to Google and type body mass index. You see a lot of information. And it will even be monitored by all of us. The body mass index must not be more than or should not be more than 35. So more than 25, you can see if you are overweight. If it's more than 30, that is obese. If someone is obese or have high body mass index, that person is very, very careful because it can lead to a lot of another things like diabetes, like cholesterol, even like cholesterol and so on. So if it is low, so you can say that it can lead to stroke. So let's leave that. So that's just it. It's body mass index. So if someone said that he's not get the result of the test by email, maybe I will try and send again. Okay, I will look at that. Any other question? Does that mean that you understand what I talked about? Should I be jumping that we understood that?
Now, please, I want to ask a question.
Ah.
Then, job satisfaction, is it a continuous variable or categorical variable?
Job satisfaction, it depends, but in this context, meaning as a continuous variable. Because here, what I intend before writing that job again is rating. And when you rate something between maybe 1 to 10 or 1 to 20, in that sense, we say it is continuous variable. So in this sense, it's a continuous variable. So what I say here. Thank you.
All right, thank you.
Any other questions? Mr. Razak.
Fine. No questions, I'm fine.
Okay. Thank you.
Thank you.
In the absence of
No questions, sir.
Just let me look into. I didn't get the result of the test, so
okay, sir. We look at it.
It's important to measure our what's it called?
Okay.
Performance. Thank you.
So I will look into it and I even maybe I will make it in Excel file and send it to the group. But I want it to be anonymous, so to be easy. So
well, it doesn't matter. It doesn't matter.
It doesn't matter. Yeah, it doesn't matter. Okay. So thank you and thanks for coming to the class. And don't forget to join at the same time by the same time tomorrow, 5:30 p.m.
Yes, sir.